Hello students, in this video we are going to discuss about gravitational potential energy, and we all know that the work done by the conservative force is independent of its path. It only depends on initial and final position of the body, and this work done by the conservative force is equal to the change in potential energy of the system. That is, whatever work is done by the system or on the system is equal to the change in potential energy of the system. And here this gravitational force is also a conservative force, and this potential energy related to the gravitational force is known as gravitational potential energy. So let's define this gravitational potential energy of a particle at any point. So here this gravitational potential energy of a particle at any point in the gravitational field of a body is defined as the work done in bringing a particle from infinity to that point. So once again, basically it is work done in bringing a particle from infinity to the point P, and that work done is equal to the gravitational potential energy. Okay, so let's derive an expression for gravitational potential energy. Derivation of an expression for gravitational potential energy. Yes. So to derive this expression, let's consider a body of mass m. Consider a body So we have to consider a body or particle of mass m in the gravitational field. In the gravitational field of another body, gravitational field of another body of mass capital M. So first we have to consider a particle or a body of mass m in the gravitational field of another body whose mass is capital M. So here there is a body, its mass is capital M, and in this gravitational field of this body we have to consider a particle or a body of mass small m, and this particle is at point P. This particle is at a point P. Okay, and here we have to find out the gravitational potential energy of a body or particle of mass small m. Okay, and to derive this expression, to derive the expression for gravitational potential energy of a particle, gravitational potential energy of a particle or a body of mass small m at a point P, mass small m at a point P, the work done in moving a particle from infinity to the point P is to be calculated, because this work done is equal to the gravitational potential energy. So we have to calculate the work done in bringing a particle from infinity to the point P, and this point P is at a distance r from the body. The point P is at a distance r from the body, and for this, the mass m is displaced from A to B through a small displacement, dx, So to calculate this gravitational potential energy, we have to calculate the work done in moving a particle from infinity to the point P, and we are not able to calculate the work done directly. So we are displacing this particle from point A to point B, and here we have considered that the point A is at a distance x from the body whose mass is capital M. Okay, now we are displacing our particle of mass m from A to B, where the distance from A to B is dx. It is dx. Okay, now first let's calculate the force on this particle of mass m exerted by the body of mass capital M. The gravitational force between the body of mass capital M and a body of mass small m separated by distance r, separated by distance x. So using Newton's law of gravitation, this force is F equals to capital G, capital M, that is mass of this body, into small m, mass of this particle, and then divided by x square. So let's call it as equation number 1, which gives the gravitational force exerted on the particle of mass small m by the particle or body of mass capital M. Okay, now the work done, that is dW, in moving a particle through a displacement dx, that we have to calculate. Okay, the work done dW in moving a particle through a displacement through the displacement dx is, it is dW, and you know the definition of work done, it is simply force into displacement, so F into dx. So what is F from equation number 1? F is capital G capital M into small m divided by x square into dx. So this gives the small work done in moving a particle through the displacement dx. Okay, let's call it as equation number 2. And it gives the small work done in moving a particle through displacement dx. Okay, now the total work done, let's calculate the total work done. So the total work done, total work done in moving a particle from infinity to point P, from infinity to point P is, okay. So to calculate the total work done, we have to integrate this equation number 2 from infinity to point P, okay. So the total work done W is equals to integration of dW, okay. And you know that this dW is, from equation number 2, is capital G capital M into small m divided by x square into dx, x square into dx. And here we are moving the particle from infinity to the point P, which is at a distance r from the body, okay. Yes, so this equation gives us the total work done in moving a particle from infinity to the point P, okay. Now this integration works only on variables, so capital G, capital M and small m taken outside of this integration function. Now this integration of 1 by x square into dx, okay, integration on 1 by x square into dx. So we all know that the integration of 1 by x square is minus 1 by x, it is minus 1 by x, and then r and infinity, upper limit is r, lower limit is infinity, okay. And now this W is equals to capital G capital M into small m into minus 1 by x. So at the place of x we are going to take r, and minus of minus 1 by infinity, then capital G capital M into small m. So 1 by infinity is 0, so simply it is minus 1 by r. So therefore the work done is equals to minus G capital M into small m divided by r. Call it as equation number 3. It is now equation number 3, okay. And this work done is stored as gravitational potential energy of the particle, okay. This work done is stored as a gravitational potential energy of the particle. This work done is stored as the gravitational potential energy of the particle, and therefore U, that is the gravitational potential energy, U is equals to W, and this U is equals to minus G capital M to small m divided by R. So this equation number 4 gives us the gravitational potential energy of a particle, okay, gravitational energy of a particle at a point P, where the point P is at a distance r from the body, okay.